All right, so we're going to start talking about logarithms. And one thing that I always want you guys to remember about logarithms is this first statement. A logarithm is another way of writing an exponent. So they are, anytime you're finding a logarithm, you are finding an exponent. So a logarithmic function with base a is defined as f of x equals, and then you have the word log. You have a subscript that is the base, so base a, and then of x. Now the x, which is what I call the argument, and we'll talk about that another day, must be greater than 0. A also must be greater than 0, the base, and a, the base, cannot equal 1. And that translates to a raised to the y equals x. Right? So that's just showing the relationship. So what we're going to do on the first couple of examples is go back and forth between logarithmic form and exponential form. So example 1 is those problems are originally written in logarithmic form, and we are going to change it to exponential form. Now, one thing I used to do in Algebra 2, and I think some of the Algebra 2 teachers do this still, is do this loop, and I kind of like the loop. So you start with the base, and you loop around like that. All right, so starting with the base, the small base of the logarithm is also the base of an exponential form, but it's a big base. All right, and then you follow the loop to the -3 is equal to the end of the loop, which is 1/8. And then ask yourself, is this true? Is 2 to the -3rd equal to 1/8? And it is, because the negative exponent makes it a reciprocal. And then we flip it over, and then 2 to the 3rd is 8. So yes, that is correct. Okay. And then for B, we're going to do the loop again. So let's start with the base, and then we'll loop around and end with the 5. So the little base of the logarithm becomes the big base, raised to the 1/2 equals 5. And then you ask yourself, is this true? So you have to know what it means to raise something to the 1/2, and I hope you know that, but it means to take the square root. So this is just another way of saying the square root of 25 is 5, which is definitely true. All right. Then for example 2, we're going to do the opposite. We have it in exponential form. We are going to write it in logarithmic form. So when you write in logarithmic form, you start with the word log. And we can still do the loop. So we're starting with the base. So the big base becomes the little base of the logarithm, log base 3 of 81 equals 4. And don't forget, a logarithm is an exponent, so the logarithm is always equal to the exponent, always. Okay, and same thing on B. So we start with the word log, and then we can do the loop if you like the loop. So log base 4 of 1/2 equals -1/2. All right, now remember, whenever you're evaluating logarithms, which is what we're about to do, that a logarithm is an exponent. The answer to a logarithm is an exponent. Okay, so we find what exponent the base needs to be raised to obtain the value. So when we get down to example 3, log base 5 of 125, you have to ask yourself, 5 raised to what power gives you 125? And that power is 3. So 3 is the answer to the logarithm. Now, they definitely get more challenging than that. So let's look at the next one. Log base 9 of 3. So you have to ask yourself, 9 raised to what power gives you 3? All right. So we started with a 9 and it got smaller. The only way that's going to happen with an exponent, that it gets smaller, but it doesn't turn into a fraction, I should say. So if it gets smaller, but doesn't turn into a fraction, then it's a fractional exponent. It's some sort of root. And the type of root it is, in this case, is the square root. So the exponent that means square root is 1/2. All right, then for C, you ask yourself 2 raised to what power is 1/16? All right, so this time it changed from an integer to a fraction. The only way that can happen is if you have some kind of negative exponent. All right, so then we need to think of how do you get 2 to get to be a 16, and that's going to be to the 4th power. So to go from 2 to 1/16, then that needs to be the -4. All right, so I have this little hint box for you. So if the value changes from an integer to a fraction, that was like the last one. We went from an integer, which is 2, to a fraction, which is 1/16, then it's going to be a negative exponent. And then when the value remains an integer, that gets smaller. That's like what we had on B. We had when 9 changed to a 3, that's going to be some sort of root. And a root is going to be a fractional exponent. So a square root is 1/2, a cube root is 1/3, 4th root is 1/4. Okay, so those can be somewhat tricky. All right, so the next thing we're going to talk about are 2 special types of logarithms, the common log and the natural log. So a common log is log base 10. And it's written without a base. Sorry, I can't spell. All right, and there's a log button in the calculator that you can see. But we're going to try to not use the calculator very much at all. All right, and the natural log is log base E. And natural log is written ln, log natural. All right, so on example 4, we are going to do the same things that we did on example 1, except we're going to either have the natural log or the common log. All right, so we could still kind of try to draw the loop if you all wanted to. Natural log is log base E, so that's going to be E. Right, so the 1.0986 is equal to 3. Now these are going to be harder for you to know if that's true. All right, and then for this one, log without a base is base 10. 10 raised to the 1.6532 is equal to about 45. I guess this one should have also been approximately. Okay, and then for example 5, we have an exponential form we want to write in logarithmic form. So remember, we're going to start with the word log. If the base is 10, we don't need to write it. If you did write it, it wouldn't be wrong. So log of 1 over 100 equals -2. Okay. And then for this one, the natural log of 20.0855 is approximately 3. All right. Then for properties of logarithms, a lot of these you can kind of just figure out. There's a couple that are a little harder to remember. But the first one I feel like is one that you could figure out. So log base A of 1 or the natural log of 1, if you ask yourself A raised to what power gives you 1, that power is 0. All right, and then log base a of a, or natural log of e, you would ask yourself, a raised to what power gives you a, or e raised to what power gives you e, and that's going to be 1. All right, and then a to what power gives you a to the x? That obviously is going to be x. Now these two over here aren't quite as obvious. So I always try to show my students on the board how this works. So if I took a and I just made it 2. Okay. So 2 raised to the log base 2 of 8. I just picked 8. All right, we would start with the numerator. And log base 2 of 8 is like 2 to what power gives you 8? And that's going to be the third power. So that's just going to be 3, right? And then 2 to the third is 8. So we did end up getting the same thing there. All right, we could try it with a different problem or different base. So let's do 3 to the log base 3 of 9. All right. So again, we would start with the power. And you ask yourself, 3 to what power gives you 9? That's going to be the second power. And 3 to the second is 9. So we ended up with that again. So what happens is a to the log base a cancels out, and you're just left with x. And the same thing happens on the e. E to the natural log of x is just going to be x. And we'll use that a lot when we start solving equations, but that won't be until after Thanksgiving. All right, so let's look at the last one. Is that these involve equations, so this is something we'll do later too. But we have log base a of x equals log base a of y. Then that means that x has to equal y. And then same thing on the natural log. If natural log of x equals natural log of y, x has to equal y. Okay. So in example 6, we're using the properties above. So I'm going to write down which property it is, and I would ask you to do the same thing just so you don't get confused if you need to look back at it later. But for A, we're trying to figure out what x is. So we have log base 7 of x equals 1. So if we're looking at our properties, the property that looks like, that looks like to me is this one, because we have the 1 there. All right, so I'm going to make a note that that's property 2. And for that to happen, the base has to equal the argument. So x would have to equal 7. All right, let me just erase that real quick. All right, let's look at B. The natural log of 3 equals the natural log of x. So if we're looking at all the properties, trying to decide which one that is, to me that looks like property number 4. All right, so that would mean that 3 would have to equal x, or x would have to equal 3. All right, and then e to the element of x equals 4. That looks like property number 3 on the right, far right side. All right, so when we have e raised to the natural log of x, the e and the natural log cancel out, and that just means that x equals 4. All right, and then the last one, log base 2 of 1 equals x. Let's take a look at all the properties. To me, that looks like this one because the argument is 1. And when the argument is 1, the exponent has to be 0. All right, so your assignment, we're going to stop there for today. We'll finish up the note sheet the next lesson. So on page 218, I want you to do 1 through 6, 8 through 20 even, 26 through 32 even, and then 74 and 76.